Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, in this particular episode of Keam Crash Course, we're going to be looking at some sample questions for physics. So we're going to be looking at some questions, analyzing their solutions, and the best way to solve them. So, let's start off with today's set. Here's our first question. Digital signals provide a continuous set of values, can utilize decimal as well as binary system, can utilize only decimal system, represent values as discrete steps, cannot utilize binary system. So, the easy way to solve this question is to describe the graph of an analog and digital signal. Now, in an analog signal, you have a continuous signal with varying amplitudes. This is analog. On a digital signal, you have two states, on or off. So the steps are discrete, and you can definitely use this in the binary system. However, you cannot use it for any other system because there are only two steps. So that means option B is incorrect, option A is incorrect because this stands for analog. Option C is also incorrect. So therefore, the correct option is option D, represent values as discrete steps. It can utilize it, so therefore option E is also incorrect. Now the reason why option D is the correct one is that it describes the values as discrete steps. And if you look at the graph, you can see that it goes on a particular value, then it goes on another value, and there's a sharp difference. Unlike amplitude, where the unlike analog, where the amplitude is constantly changing, which means there's a continuous distribution. So therefore, option D is the correct option for this question. Now let's look at another question. Two physical quantities, P and Q, have different dimensions. The physically meaningful mathematical relation is P plus Q, P minus Q, P by Q, P minus Q by Q, P plus Q over Q. Now, this comes from the chapter Units and Dimensions, and in that particular chapter we talked about SI units, dimensional analysis, etc. Now, in this particular question, we have two physical quantities having different dimensions. So, which is the physically meaningful mathematical relation? Now, when something has different dimensions, that means operations such as addition and subtraction are incorrect. Whereas if you try multiplication or division, these operations can be done. The reason being that for addition and subtraction you need same dimensions, while for multiplication and division that's not always the case. So if you look at our options, you can see that option A is incorrect, B is incorrect, because it's addition and subtraction. Options D and E are incorrect because in the numerator there is an addition or subtraction, which is not possible with something for different dimensions. Now, if this is going over your head, then think of it this way. Let's say you have mass and volume. Can you add mass and volume together? No, it doesn't make sense. However, you can divide mass with volume to get density, which is a different unit. So therefore, option C, P by Q, is the correct option. Now, P and Q are different dimensions, so therefore, a mathematical relation such as division works for it. However, addition and subtraction does not work for physical quantities with different dimensions. Now, let's look at the final question for the day. In one dimension, the angle between velocity vector and an acceleration vector of an object is. either 0 or 180 degrees, between 0 and 180 degrees, between 90 and 180 degrees, more than 180 degrees, 90 degrees. So, how do we solve this question? Well, the question says at the beginning in one dimension. So here we're dealing with motion in a straight line. So 1D means one particular dimension, which is length. So you have an object, it goes with the velocity v. Now there are two ways that you can accelerate it. You can either speed it up or slow it down. So you can push the you can accelerate in the direction of the velocity vector, speeding it up, or you can take the exact opposite direction, like you can accelerate in the exact opposite direction, slowing it down. You can't use any other direction such as up or down because we're dealing with one dimension. So if you have velocity and acceleration in the same direction, then the angle between them would be 0 degrees. On the other hand, when velocity is directly opposite to acceleration, you have an angle of 180 degrees between them because they're directly opposite. So therefore, the correct option among the following is option A, either 0 or 180 degrees. B says between 0 and 180, that means it has to be motion in a plane, which is incorrect. Again, C says between 90 and 180, but then that can only happen in motion in a plane. It doesn't happen in a straight line. More than 180 degrees, again, that's in a plane when you have reflex angles. And option E, 90 degrees, you have that occurs in projectile motion, which is motion in a plane. So therefore, options B, C, D, and E are incorrect. The right answer is option A, either 0 degrees or 180 degrees. And the reason for that is that you can only, in a straight line, you can only accelerate an object with a velocity v either forwards or backwards. So you can either push it in the same direction or push it in the diametrically opposite direction. So therefore, option A is the correct option. Now that concludes this episode of Keam Crash Course. We hope you found it interesting. To learn more about us and to get more useful and interesting educational content, don't forget to subscribe to Agile Rank Mate, and you can also hit the notifications icon to receive our latest content. So, until the next webisode, take care, stay alert, bye-bye for now.